Now number 3. So on number 3, we have f of x equals x squared over x squared minus 3x minus 4. That was a little bit sloppy, but we'll fix that. Doesn't really matter. Alright, so domain comes first. Domain. We're going to look at that bottom term, x squared minus 3x minus 4. Set that bad boy not equal to 0. Factor it out. So we get x minus 4 and x plus 1 cannot equal 0. So x cannot equal 4. X cannot equal negative 1. Since nothing in the numerator and denominator cancel each other out, we know that in this case, both the negative 1 and the 4, they will both be vertical asymptotes. Since nothing canceled, there are no holes. The degree of the numerator and the degree of the denominator are equal. They are both 2. And so the horizontal asymptote is going to be the ratio of the lead coefficients. So lead coefficient of the numerator is 1. Lead coefficient of the denominator is 1. So the horizontal asymptote is at y equals 1. X-intercept, if x squared equals 0, then our x-intercept is at 0, 0. Since the x-intercept is 0, 0, the y-intercept is also 0, 0. There is no constant associated with the x squared term, so that ratio is 0 over whatever. That leaves us prepared to graph the function. We have vertical asymptote at negative 1. We have a vertical asymptote at 1, 2, 3, 4. We have a horizontal asymptote at 1. And we have an x-intercept at 0, 0. Now, notice this x-intercept is degree 2, so it's going to bounce. What we don't know is it going to bounce above, or is it going to bounce and be below? So we plug in one of the numbers to see, are we getting positives or negatives? So what if we plug in 1? So if I plug 1 in, we get that f of 1 equals 1 squared divided by 1 minus 4 times 1 plus 1. So that's going to be positive over negative times positive. So this is going to be a negative number. So at 1 we are negative, which means this thing has to do something like that. We know it bounces because the x is squared, and it is below the axis because when we plug in the 1, we get out a negative number. Now we have to determine what it does on both of the edges. But in this case, this is a pretty simple question to answer. Because there is no additional x-intercept, if we were below here or here, we would have to cross the x-axis again at some point. Since there is no x-intercept in either one of those areas, we immediately know that the graph has to do something like that.